Welcome to Science to Sleep By, the channel where the mysteries of the universe meet the comfort of the night. Tonight, we explore a breathtaking chain of events, a celestial visitor known as Three-Eye Atlas, a world shaken by earthquakes, and a sun that seemed to answer back. Get comfortable, your mind drift among the stars, and allow science to carry you softly into sleep, in the vast stillness of the cosmos. Far beyond the comforting glow of Earth's atmosphere, there drifts an object both ancient and unfamiliar. Three-Eye Atlas. It is neither a simple comet nor a quiet asteroid. It is a traveler between stars, a messenger from regions of space where light takes millennia to wander. Its path through the solar system has been traced, charted, and studied, yet there remains something inexplicable about its journey, a silent pulse that seems to echo through both space and time. On certain nights, as astronomers observed its trajectory, the data suggested subtle changes, faint adjustments in its spin, as though responding to something unseen. This was not just a fragment of rock moving through emptiness. It felt, in some mysterious way, alive to the harmonies of the universe. The story of Three-Eye Atlas begins, like many others in astronomy, with curiosity. Scientists first noticed its unique behavior as it approached the inner solar system, traveling with an unusual velocity and a spectral signature unlike any other known interstellar visitor. But the real intrigue began when Earth itself seemed to stir. Beneath the crust, tectonic plates shifted with renewed force, generating seismic tremors that rippled across oceans and continents. It was a time when the planet's heartbeat grew louder, a rhythm felt in the soil, the air, and even the instruments orbiting high above. Somewhere amid that global vibration, something within Three-Eye Atlas seemed to change. It began as an anomaly, a subtle alteration in its reflective surface, a shift so delicate it was almost imperceptible. The object's brightness fluctuated, its albedo data showing tiny spikes, as though sunlight was striking a newly awakened facet of its body. Some dismissed it as coincidence, as nothing more than an interplay of data and timing. But for a handful of researchers who believed in the intricate connectivity of cosmic systems, this overlap between Earth's trembling and the asteroid's shifting signature was too synchronistic to ignore. They began to wonder, could seismic waves, born deep within Earth, somehow ripple outward through magnetic fields, atmospheric layers, and solar winds to influence a distant traveler like Three-Eye Atlas? The idea seemed extraordinary, yet the universe often defies the boundaries of simple logic. Space is not empty. It is a web of energies, particles, and resonances. Every planet, star, and wandering fragment hums with frequency and invisible tone within the grand symphony of existence. When Earth quakes, that sound doesn't end at its surface. It radiates outward, an electromagnetic whisper that joins the solar breeze and drifts into interplanetary space. For something as sensitive as Three-Eye Atlas, already battered by cosmic rays and interstellar dust, even a faint surge in solar plasma could alter its behavior ever so slightly. In observatories across the world, instruments recorded the timing, moments after a series of deep tremors along the Pacific fault lines. Spectral readings from Atlas began to shift. The rotation pattern, once stable, showed signs of turbulence. The data could not conclusively link the two events, yet the coincidence fascinated scientists and storytellers alike. What if this was not mere chance? What if our planet's movement, its breathing, its tectonic motion resonated across the void, brushing the surface of a celestial body millions of miles away? As these questions swirled among late-night researchers, the public began to take notice too. Space forums buzzed with speculation, documentaries whispered about Earth's echo in the stars, and astronomers quietly cross-checked readings from the Solar Dynamics Observatory. For a brief time, it felt as though humanity stood on the edge of discovering something profound, not just about space, but about the subtle, unseen ways the universe communicates. Three-Eye Atlas became a symbol of cosmic sensitivity, a mirror to Earth's hidden energy. Its surface, once thought inert, seemed to shimmer faintly with a bluish hue as it caught sunlight filtered through solar wind charged by geomagnetic disturbances. This hue wasn't just visual beauty, It was a story written in light, a potential record of interactions between terrestrial tremors and solar activity. Scientists knew they needed more data, but deep within those observations lay a poetic truth, that perhaps no event in the universe happens in isolation. For those who study celestial mechanics, the relationship between solar storms, planetary magnetism, and interstellar matter has long been a subject of wonder. The sun's flares are not random. They follow cycles, responding to magnetic harmonies that stretch across the heliosphere. Earth's inner core spins in resonance with these same fields, its iron heart vibrating faintly in tune with solar rhythms. If that harmony can reach Earth's mantle, perhaps, through layers of gravity and light, it can reach 3i Atlas as well. In that sense, the object becomes less an outsider and more a participant in our cosmic neighborhood, a being that moves not independently, but in response to a greater universal rhythm. Imagine standing beneath a clear night sky, the stars glimmering with quiet intelligence. Each one sends its vibration across the void, and Earth, in all her geological restlessness, replies. When tectonic plates collide and mountains groan beneath the crust, those sounds ripple outward, meeting the solar wind and mingling with the radiation that shapes comets and asteroids. To think that one of these wanderers, 3 Atlas, might have subtly changed in response to that echo is to glimpse the unity of creation itself. In the silence of interstellar space, time moves differently. What seems like coincidence to us might be harmony to the cosmos. When Earth shook, and the sun's fields trembled, 3i Atlas might have heard the resonance not in sound, but in light, motion, and frequency. The idea is both comforting and humbling. It reminds us that the boundary between our planet and the heavens is not as firm as we imagine. We are part of an immense, breathing system, a dialogue written in magnetism, radiation, and movement, linking us to the stars that cradle our existence, and ancient travelers that pass briefly through our realm before returning to the dark beyond when the earth trembles. It does more than shift the ground beneath our feet. Deep within its molten core, the planet hums with frequencies that ripple outward through rock, water, and sky. These vibrations, born from tectonic collisions and internal energy, create a kind of music, one that never ceases. Scientists have long recorded this subtle background hum of the planet, even when no earthquakes occur. But when those moments of immense stress arrive, when the crust fractures and waves of energy spiral through the mantle, the song grows louder, more insistent. What most people experience as chaos, collapsing buildings, shaking land, and roaring seas may also be, on a cosmic scale, a transmission of raw energy that travels far beyond the atmosphere. In the moments following a powerful earthquake, the planet's electromagnetic field surges. Instruments designed to measure magnetospheric changes have captured faint fluctuations in geomagnetic intensity just as seismic waves pass through the crust. It's as if the Earth's heartbeat pulses outward, rippling through the invisible shield that protects it from solar radiation. Those magnetic pulses move upward, merging with the charged layers of the ionosphere, where they interact with solar, wind, and cosmic rays. It is here, high above the world of sound and weather, that the line between Earth and space begins to blur. For decades, geophysicists have studied the strange connection between seismic activity and space weather. The data, though subtle, suggests that under rare and extreme conditions, an earthquake can influence electromagnetic conditions in near-Earth orbit. The mechanism isn't magic. It's physics, the conversion of mechanical stress into electromagnetic signatures. When the crust bends and breaks, piezoelectric minerals like quartz generate small electric currents. These currents interact with the surrounding magnetic field, sending faint but measurable signals skyward. Normally, these signals are weak, dissipating within the lower atmosphere. But during periods of solar unrest, when charged particles saturate the magnetosphere, these terrestrial signals can be amplified, carried outward like whispers in a storm. This brings us to a fascinating speculation. Could such energy, radiating outward from the planet's interior, extend even farther, across millions of miles to touch something like 3i Atlas? Theoretically, Electromagnetic disturbances can propagate through the solar plasma, though their strength diminishes with distance. However, resonance, the phenomenon where one vibrating system amplifies another at a matching frequency, could make such interactions more profound than we currently understand. If Earth's geomagnetic resonance momentarily aligned with solar oscillations, that amplified signal might reach a threshold where even distant interstellar visitors could sense the change. While traditional astronomy focuses on gravitational and kinetic forces, a growing number of researchers are exploring the subtler connections, magnetic coupling, plasma resonance, and field interactions that bind celestial bodies in ways invisible to the eye. During significant earthquakes, sensors aboard satellites such as NASA's Themis and ESA's Swarm mission have occasionally recorded minor irregularities in the near-Earth magnetic environment. Some of these disturbances coincide with shifts in solar wind patterns or faint changes in cosmic ray flux. These are small correlations, yet they hint at a deeper dialogue between the Earth's internal motions and the larger solar system environment. From a geophysical perspective, the planet behaves like a massive dynamo, a self-sustaining generator powered by the movement of molten iron within its core. This dynamo creates Earth's magnetic field, which constantly interacts with the solar magnetic field. When a strong earthquake occurs, it momentarily alters the flow of energy and tension within the crust, subtly modifying the electric and magnetic balance at the surface. These alterations could produce micropulses that travel outward, carried by magnetic field lines extending into space. Though the strength of these pulses is small, they join an already dynamic system, the solar wind, a river of charged particles that connects every object within the heliosphere. In this way, an earthquake on Earth becomes a note added to the universal current of energy flowing through the solar system. The 3I Atlas incident raised this idea to new levels of curiosity. When scientists reviewed seismic data from the week surrounding the observed changes in Atlas's reflective pattern, they found that Earth had experienced a cluster of moderate but deep earthquakes beneath the Pacific plate. These quakes were strong enough to send seismic waves across the planet and produce brief electromagnetic bursts detectable by satellites. What fascinated researchers was the timing. Just days after the seismic cluster, observatories reported an anomalous flicker in the spectral readings from Atlas. Was it coincidence? Or had Earth's energetic shift resonated outward in ways we barely comprehend? At the same time, the Sun was entering a period of magnetic instability. Solar observatories recorded minor coronal holes and weak flare activity. The solar wind carried this turbulence toward Earth, compressing the magnetosphere slightly and heightening its sensitivity. This perfect alignment of events, seismic energy from below, solar wind pressure from above, created a moment of exquisite cosmic balance. In that instant, every layer of interaction between Earth, Sun, and interplanetary space pulsed with heightened potential. If a distant traveler like 3I Atlas was positioned within the subtle extension of that energy field, it could have experienced the effects not as a direct force, but as a resonance, a soft nudge from the invisible network connecting all matter. Under the Sun, scientists describe such phenomena using the language of magnetohydrodion, as the study of how magnetic fields and conducting fluids or plasmas interact. But beneath the mathematics lies a simple, poetic truth. Everything vibrates, and vibrations seek harmony. When Earth trembles, the universe listens. Though this may sound metaphorical, the science of resonance supports the notion that all energy waves, no matter how faint, have the potential to influence distant systems if conditions align. The same principle allows tuning forks to resonate across a room, or radio waves to traverse the emptiness of space. From this perspective, an earthquake becomes more than a geological event. It is a release of ancient energy, a breath from the deep, sending information outward into the universe. The quaking of the ground, the flicker of the ionosphere, the trembling of magnetic fields, all are part of one continuum of motion. The cosmos does not separate what happens below the crust from what happens in the heavens. Both are expressions of the same underlying energy that shapes stars, planets, and comets alike. When the Earth shifts, it participates in that ongoing conversation, its voice, carried by waves of invisible force, reaching into the cosmic ocean, where objects like 3I Atlas drift in quiet observation. When the first reports about 3I Atlas began circulating through the astronomy community, most scientists regarded it as another intriguing visitor, a faint point of light crossing the field of deep space telescopes, distant yet measurable. It was classified as an interstellar object, the third known of its kind, following in the wake of Oumuamua and Borisov. But there was something about 3I Atlas that didn't behave according to prediction. Its brightness curve fluctuated in strange intervals, and its rotation period appeared to drift in subtle, unexpected ways. Normally, interstellar objects follow patterns that can be modeled by gravitational mechanics and reflected sunlight, but Atlas refused to be so easily defined. As its trajectory passed through the inner solar system, observatories on Earth and in orbit began collecting data that would soon reveal an anomaly unlike anything seen before. It began with the readings from the Pan-STARRS Observatory in Hawaii and the Hubble Space Telescope, which together tracked the object's shape, spin, and reflectivity. The early model suggested that 3I Atlas was breaking apart, a sign of structural weakness caused by its journey close to the Sun. Yet, when the breakup should have resulted in a predictable dimming pattern, something else happened. Instead of fading, the object's brightness increased slightly, as if it were being energized or resurfaced by an unseen process. Scientists at the European Southern Observatory were among the first to notice that the light curve contained an unusual modulation, a rhythmic fluctuation that did not match known rotational models. The data seemed to imply that the object's surface was not uniform, but changing over time. Then came the timing. In a narrow window of observation, right after a series of strong seismic events on Earth, a few research groups recorded small but measurable spectral shifts in Atlas's reflected light. Normally, such variations could be attributed to observational noise, atmospheric distortion, or instrument calibration. But this pattern was consistent across multiple telescopes stationed on different continents and in orbit. The signal, though faint, suggested that the chemical composition of the object's surface had changed in some way. There were traces of altered sodium emission lines, a marker that could indicate solar heating, ionization, or exposure to a charged particle burst. At NASA's Goddard Space Flight Center, astrophysicists began comparing the Atlas data with solar activity logs from the same period. To their surprise, a minor solar flare had indeed occurred, accompanied by a surge in geomagnetic activity detected on Earth. It was the kind of low-level solar disturbance that often goes unnoticed, except by satellites and instruments tuned to the Sun's subtle behavior. The correlation between the flare, the geomagnetic spike, and the changes in Atlas's light signature raised a provocative possibility that the object might have been influenced by a chain reaction initiated by Earth's own geophysical state. The data from the Solar and Heliospheric Observatory (SOHO) added a layer of complexity. As Earth's magnetic field reacted to the solar event, particles from the Sun's plasma stream fluctuated, bending slightly under electromagnetic variations. This was not a dramatic flare or storm. It was a small, almost imperceptible shift in the heliospheric current. Yet at the scale of interplanetary plasma, even minute variations can alter the way sunlight scatters or how charged dust behaves. If Atlas was positioned along one of those plasma conduits, the faint echo of that event might have interacted with its ionized tail or crustal surface, changing its reflective properties and the pattern of gas release. The James Webb Space Telescope later contributed infrared data showing a delicate thermal asymmetry. One side of Atlas appeared warmer than expected, while the other side cooled more rapidly. It was as if the object had absorbed a sudden burst of energy and then released it unevenly. In most comets or asteroids, this could be attributed to the sublimation of ice or a change in spin orientation, but the timing once again hinted at a deeper connection. The anomaly persisted for several weeks before returning to a more stable state, suggesting a transient but significant event had occurred. Among the teams analyzing these findings was a small group of plasma physicists who specialized in cosmic dust interactions. They proposed that 3I Atlas might have encountered a charged particle field whose source could be indirectly linked to Earth's magnetospheric reaction during seismic upheaval. When large-scale earthquakes occur, they can induce electromagnetic perturbations that extend far beyond the ionosphere. These, in turn, can interact with solar wind particles that spiral along magnetic field lines stretching deep into interplanetary space. Such a mechanism would be delicate and rare, but not impossible. The universe, after all, operates through resonance and response. And even a faint signal can create ripples across the solar plasma if conditions align perfectly. The European Space Agency's data center in Darmstadt. Analysts cross-referenced the Atlas spectral changes with readings from space-based radiation monitors. They discovered that in the days following the seismic cluster, there was an unexpected increase in high-energy particle density near Earth's orbit, not large enough to cause alarm, but statistically notable. The anomaly coincided almost precisely with the period during which Atlas exhibited its optical irregularities. This coincidence reignited debates about whether planetary events and solar dynamics could momentarily synchronize, creating windows of mutual influence. Ground-based observatories added to the mystery. Amateur astronomers equipped with sensitive CCD cameras reported observing faint coloration shifts in Atlas's coma from a pale greenish hue to a bluish tint, typical of ionization under energetic particle exposure. The shift matched known wavelengths associated with CN and C gas emissions, common in comets undergoing photochemical reactions. But the pattern of these emissions was inconsistent with solar proximity alone. The object was too far from the Sun to experience such intense ionization naturally, implying that a temporary surge in charged particle flow might have reached it. Scientists working with magnetometer data proposed another angle, that the interplanetary magnetic field might have briefly oscillated in response to geomagnetic variations triggered by the solar flare and Earth's internal vibrations. In such a complex environment, energy doesn't travel linearly, it resonates, refracts, and merges with other frequencies. 3I Atlas, being composed of dust, ice, and metallic compounds, could have acted like a receiver, responding to those oscillations by shifting its spin or releasing trapped gases in bursts invisible to the naked eye but detectable in the spectrum. These findings didn't go unnoticed by the media. Within weeks, science forums and late-night programs were discussing the possibility that Earth's earthquakes and Atlas's behavior were somehow linked. Some framed it as a coincidence, others as evidence of a subtle cosmic feedback loop between our planet and interstellar matter. In scientific circles, caution prevailed. Correlation is not causation, yet the intrigue deepened. Each new observation reminded researchers of the profound interconnectedness of celestial and terrestrial systems. Even if the connection was symbolic, the data compelled them to ask larger questions about how energy moves through the universe and how planets, stars, and traveling fragments like 3I Atlas might participate in a shared field of influence. The most astonishing revelation came from spectral decomposition data showing that after the observed anomaly, Atlas's reflectivity never fully returned to its original state. A slight enhancement in its albedo persisted, as if its surface had been microscopically altered, glazed by radiation, or fused by a burst of charged particles. It was a small change, one easily overlooked in the vast ledger of cosmic events. But to those watching closely, it represented a whisper of something far greater. A subtle moment when the trembling of a world and the drift of an interstellar traveler seem to converge in the quiet language of light. In the heart of our solar system burns the Sun, a colossal sphere of plasma, weaving magnetic threads and radiating waves of energy that reach every corner of its dominion. Its light sustains life on Earth, but its deeper forces extend far beyond warmth and illumination. Within the Sun's churning depths, magnetic lines twist, snap, and realign in patterns so intricate that even the most advanced models struggle to capture their true complexity. These invisible interactions create what scientists call the solar dynamo, an immense generator that controls the behavior of everything from gentle solar breezes to violent coronal mass ejections. When even a small disruption occurs within this system, the effects can cascade outward through the heliosphere, the vast bubble of solar influence that encloses every planet, moon, asteroid, and interstellar traveler. Like Three-Eye Atlas, the heliosphere is not empty space. It is filled with the solar wind, a continuous flow of charged particles moving at hundreds of kilometers per second. This wind carries with it the sun's magnetic field, stretched into long, spiraling shapes that form what scientists call the Parker spiral. Every fluctuation in the sun's surface, every magnetic shift, is carried outward along these lines of plasma, reaching far-flung worlds and even the most distant edges of our solar system. When a solar flare erupts, the sudden burst of electromagnetic energy ripples through this ocean of charged particles, disturbing everything in its path. The event may last only minutes on the sun's surface, but its echo can take days to cross the vast distance to Earth and beyond. It was during one such event, subtle by solar standards, but significant in timing, that the strange behavior of Three-Eye Atlas began to deepen. Instruments monitoring the sun detected a small but sharp rise in X-ray emissions followed by a minor coronal ejection. The energy from this flare streamed outward, carried by a fast-moving plasma current that briefly intensified the solar wind. On Earth, the magnetosphere compressed slightly, causing faint auroral activity near the poles. It was not a major event, not the kind that disrupts satellites or communication networks. Yet it arrived precisely during the period when Earth's crust was vibrating with seismic unrest, and when telescopes were observing minor anomalies in Atlas's light spectrum. In this synchronized moment, the interconnectedness of solar, terrestrial, and interstellar phenomena became apparent. The flare's electromagnetic pulse interacted with Earth's field, creating geomagnetic fluctuations that registered on satellite magnetometers. Those same fluctuations altered the propagation of electromagnetic signals through the upper atmosphere, which in turn affected the ionization layers that help regulate the escape of particles into space. From there, the energy merged with the solar wind, becoming part of a complex chain reaction stretching from the sun's corona to the far reaches of the heliosphere. The question scientists began to ask was whether this surge of solar energy, enhanced by Earth's magnetic feedback, could have extended its reach far enough to influence an object like Three-Eye Atlas. At first glance, the idea seemed improbable. The vast distances between celestial bodies make direct cause and effect interactions rare. Yet, in plasma physics, distance behaves differently than it does in empty space. The solar wind is not a void, but a conductive medium, an ocean through which electromagnetic waves can travel, amplify, and sometimes resonate. In this environment, waves can merge and grow stronger when their frequencies align, much like overlapping ripples on a pond. When the solar flare erupted, it likely sent a wave of magnetosonic energy through the plasma. As it moved outward, it passed through regions of varying density, bending and reflecting along the way. If at any point these waves encountered another disturbance, such as Earth's electromagnetic pulse following its seismic activity, they could have interfered constructively, producing a localized surge in plasma intensity. This surge, small on the scale of the sun, might have been sufficient to alter the conditions around Three-Eye Atlas as it traveled through the heliosphere. The instruments aboard the Solar and Heliospheric Observatory captured subtle shifts in solar wind speed around this period, confirming that small-scale energy waves had propagated outward. Meanwhile, NASA's Parker Solar Probe recorded fluctuations in magnetic field strength consistent with transient solar activity. These observations aligned with data from space weather monitoring satellites orbiting Earth, which detected a brief but measurable increase in high-energy particles, a signature that often accompanies solar-triggered chain reactions. In this delicate interplay, Three-Eye Atlas became a passive participant in a system far greater than itself. The sun's eruption, Earth's magnetic echo, and the propagation of charged particles through interplanetary space formed a web of connection. Each node of this web, the solar surface, the Earth's ionosphere, the drifting body of Atlas, was linked by a common thread of energy. The object's surface, composed of volatile compounds and metallic dust, would have reacted immediately to any variation in solar flux or charged particle density. Even a slight change in plasma exposure could cause sublimation, ionization, or the release of trapped gases from its surface. Such reactions could explain the unusual brightness fluctuations and color shifts observed by telescopes during this time. In scientific terms, this is known as a feedback event, a process in which energy originating from one source cascades through multiple systems, each influencing the next in subtle but measurable ways. The sun's flare did not directly target Atlas, yet the energy it unleashed created conditions that made the object more reactive. The heliosphere acts as both conduit and amplifier, ensuring that no event, however small, exists in isolation. The plasma that fills the space between worlds acts like a vast nervous system, transmitting impulses and vibrations that connect everything under the sun's influence. Researchers studying the event later simulated how electromagnetic waves from solar activity could interact with the charged interstellar object. Their models showed that under specific conditions, magnetic reconnection events where magnetic field lines break and realign could produce energy pulses capable of altering the motion of dust and ionized material around a comet-like body. In other words, the solar trigger might not have physically moved Atlas, but it could have changed its surface structure and the way it scattered light. This idea, though still theoretical, revealed something profound about the heliosphere itself. It is not a passive region through which planets orbit, but a dynamic, living field where every fluctuation, from an earthquake on Earth to a ripple on the sun's surface, contributes to the greater rhythm of cosmic energy. Within this system, 3i Atlas was not an outsider, but a participant, a silent observer whose behavior offered a glimpse into the deeper mechanisms of universal resonance. What made this episode so fascinating was the scale of subtlety involved. The energy shifts were not catastrophic. They were delicate, nearly invisible, yet powerful enough to reshape our understanding of interplanetary relationships. The sun, in its immense power, had once again reminded us that even the smallest solar tremor could ripple through the vast web of creation, influencing the fates of distant travelers. Suspended within its luminous reach, every object in the universe vibrates. From the dense heart of a star to the drifting body of an asteroid, every atom hums with its own frequency, a silent rhythm that, when combined with others, forms the great cosmic symphony of existence. Scientists call it resonance, a principle that governs not only music and sound, but also matter, energy, and light. Resonance is the reason bridges can sway with wind, glass can shatter with tone, and orbits can stabilize across millions of miles. But when planetary frequencies align, when the subtle oscillations of one celestial body synchronize with another, the universe seems to communicate in ways both mysterious and profound. The idea that Earth's vibrations could interact with solar fields, or even reach an interstellar traveler like 3 Atlas may seem fantastical, but resonance is not magic. It is physics, expressed through harmony. Within the planet, resonance takes many forms. The Earth itself hums constantly, emitting frequencies known as the Schumann resonances. These are electromagnetic waves trapped between the surface and the ionosphere, oscillating primarily around 783 Hz. They are generated by lightning strikes, atmospheric charge, and the planet's own magnetic heartbeat. When seismic activity occurs, those frequencies spike and fluctuate, as if the Earth's song has been momentarily disturbed. These changes do not stop at the edge of the atmosphere. They travel outward, blending with solar wind and magnetic fields that encircle the planet. Some scientists believe these electromagnetic pulses can resonate with the sun's own oscillations, creating moments of temporary alignment, a kind of planetary chord played across the heliosphere. The sun, for its part, is not silent. Beneath its blinding light, pressure waves continuously pulse through its plasma body, producing low-frequency vibrations known as helioseismic oscillations. These waves cause the surface of the sun to expand and contract by tiny amounts, in patterns that can be detected and measured by solar observatories. the entire solar sphere rings like a bell, its deep tones resonating through space in wavelengths that can influence the behavior of charged particles and magnetic fields. When these solar rhythms align with Earth's magnetic fluctuations, perhaps during times of increased seismic stress, the two bodies may enter a state of temporary resonance. This alignment amplifies electromagnetic coupling, allowing energy to transfer more efficiently between the Sun, Earth, and the surrounding plasma environment. In the case of 3I Atlas, this theory gains particular intrigue. During the period of its observed anomalies, both Earth and the Sun were undergoing energetic disturbances. Earth's crust was releasing seismic vibrations, while the Sun emitted a minor flare that propagated through the solar wind. The resonance theory suggests that these events could have overlapped in frequency, creating a field of amplified interaction that extended into space. In such a moment, the heliospheric currents might have intensified locally, producing wave fronts of energy that reached Atlas. The object, composed of conductive materials like metallic dust and frozen gases, would have responded to these oscillations by shifting its own internal balance, a tiny, almost imperceptible adjustment that nonetheless manifested as changes in brightness and rotation. To understand how resonance works on this scale, one must think of the universe as a vast network of vibrating strings. Each planet, each particle of dust, contributes its note to the overall harmony. When two notes share the same frequency, or harmonic relationship, they resonate, exchanging energy through vibration. In human experience, this is seen in music. Strike one tuning fork, and another of identical pitch begins to hum without being touched. The same principle governs gravitational tides, orbital synchronization, and even the stability of planetary systems. Moons orbiting gas giants often lock into resonant ratios, such as the 1:2:4 pattern of Jupiter's moons, Io, Europa, and Ganymede. These natural harmonies maintain balance within the gravitational field, preventing chaos. If resonance can shape the motions of moons, it may also influence the more delicate interactions of magnetic and plasma fields between Earth and interstellar space. In recent decades, researchers studying magnetohydrodynamics, the movement of electrically charged fluids under magnetic influence, have discovered that resonance can occur even between separate plasma systems. When the oscillation frequency of one magnetic field matches another, energy transfer becomes exponentially more efficient. This phenomenon has been observed between the Sun and Earth, where solar wind oscillations sometimes synchronize with geomagnetic field lines, producing enhanced auroras and fluctuations in satellite communications. If such synchronization were to extend beyond Earth's immediate environment, reaching a drifting interstellar object like 3I Atlas, it could create a subtle electromagnetic interaction, detectable only through minute physical changes. What makes resonance particularly fascinating is its sensitivity. A small adjustment in frequency or phase can shift a system from harmony to dissonance. The same principle applies in nature, a delicate balance of forces that allows planets to orbit stably and atoms to bond consistently. When Earth's internal energy spikes during seismic events, its magnetic field can temporarily alter its oscillation rate, nudging the planet's natural resonance toward frequencies closer to those of solar oscillations. If, during such a time, the Sun's own frequencies also shift due to a flare or coronal disturbance, their harmonics might align briefly, creating a bridge of resonance across millions of miles. Through that bridge, electromagnetic waves and charged particles can flow with amplified coherence, affecting everything in their path. For 3I Atlas, positioned within the heliosphere's fluctuating currents, such a bridge could have translated into a change in local plasma density or magnetic orientation. The object's surface, coated in volatile compounds, may have responded by releasing gas in irregular bursts or by subtly changing its reflective properties. Observers on Earth would perceive this as a flicker or color shift, the same anomaly recorded in the data. The event would not have been an act of force, but of resonance, an invisible handshake between the frequencies of Earth, the Sun, and a distant traveler. Even within our own bodies, resonance plays a quiet role. The human brain, the heartbeat, the cycles of sleep and consciousness, all oscillate in measurable rhythms that sometimes mirror the natural frequencies of the planet itself. This connection between biological and planetary resonance has long intrigued scientists and philosophers alike, suggesting that life may be more deeply integrated into the cosmos than we realize. In this context, the events surrounding 3I Atlas seem less like isolated phenomena and more like part of a universal pattern, where energy aligns and realigns in waves of mutual influence. As researchers examined the data, they began to consider that resonance might be one of the fundamental languages of the universe, a medium through which stars, planets, and matter communicate across incomprehensible distances. The alignment of frequencies, whether mechanical, electromagnetic, or gravitational, could explain why certain cosmic events appear synchronized despite their separation in space. The universe, after all, is not static. It is dynamic, filled with vibration and rhythm. When one part of the system shifts, the rest responds, sometimes subtly, sometimes dramatically. In this living network of frequencies, Earth's earthquakes, the sun's flares, and the shimmering behavior of 3I Atlas become connected not by coincidence, but by resonance. The timeless conversation of energy that binds all matter within the same cosmic sanjan. The intricate dance of cosmic physics. Every event is a chain reaction waiting to unfold. One motion gives birth to another, one vibration stirs the next, and before long, what began as a tremor deep beneath the Earth's crust can ripple outward to influence forces far beyond the atmosphere. This is the foundation of what scientists and theorists have come to call the solar trigger hypothesis. The idea that seismic activity on Earth and electromagnetic responses from the sun are not isolated occurrences, but interconnected through a web of charged energy, plasma flow, and resonant frequency exchange. In this framework, when Earth shakes, the sun listens, and sometimes it answers back. During the observed period in which 3I Atlas began to exhibit its unusual behavioral shifts, data showed an overlapping increase in both geomagnetic fluctuation and solar activity. What made this timing fascinating was that several Earth-based seismic disturbances, minor earthquakes, recorded along the Pacific Rim occurred within hours of these solar magnetic spikes. It led researchers to re-examine the delicate electromagnetic relationship between Earth and the Sun. For decades, science has known that solar flares and coronal mass ejections can impact Earth's magnetosphere, causing geomagnetic storms and auroras. But what if the process can also flow in reverse? Could Earth's electromagnetic upheaval, triggered by seismic strain and crustal shifts, send reactive signals back through the solar wind enough to disturb or amplify solar fields in localized regions? The solar trigger hypothesis begins here, at the intersection of geology and astrophysics. When tectonic plates grind against one another, they release immense mechanical energy. Much of it dissipates as heat and vibration, but a portion radiates as electromagnetic energy. Rocks under stress generate what's called piezoelectric discharge, the release of electric charge caused by pressure changes in crystalline minerals like quartz. These discharges can generate low-frequency electromagnetic waves that propagate through the atmosphere and ionosphere. In large enough quantities, these waves might distort the ionospheric plasma field, momentarily altering its density and charge. The Earth's ionosphere, being directly coupled to the magnetosphere, responds to these changes by adjusting its electromagnetic configuration. This perturbation then travels along magnetic field lines, outward toward interplanetary space. Once such energy disturbances enter the solar wind, the stream of charged particles emitted by the sun, they can create a form of feedback interaction. The solar wind is not a simple breeze of particles. It is a complex plasma medium filled with fluctuating electromagnetic waves. Any new wave introduced into it can modify its flow pattern or resonate with existing waves. In theory, if Earth's magnetospheric discharge matched certain frequencies in the solar wind's plasma oscillations, it could momentarily amplify wave structures traveling toward the sun. Though the energy magnitude would be small, resonance could enhance its effect locally, producing a minor fluctuation detectable within the sun's surface magnetic behavior. This could act as a trigger, a tiny external pulse that nudges a preloaded solar system into activity, much like a small vibration that causes a balance-sensitive machine to react. Around the same timeframe as Earth's seismic movements, solar observatories detected a modest uptick in ultraviolet radiation and magnetic disturbance localized near the solar equatorial region. These were not significant flares but small-scale brightenings, microflares which seemed to coincide within hours of the seismic spikes recorded on Earth. Though mainstream science attributes such events to internal solar turbulence, the correlation has intrigued theorists who study planetary scale coupling. If Earth can feel the influence of solar magnetism, then logically, under certain resonant conditions, the reverse must also be possible. Earth could act as a subtle stimulator of solar feedback. When the solar field responds to such a disturbance, it can release localized bursts of energy, including charged particle surges and radio wave emissions. These disturbances travel outward again, riding the solar wind, and eventually pass through the region where interstellar objects like 3I Atlas reside. For an object already sensitive to electromagnetic fields, especially one composed of a conductive mixture of metals, carbon, and volatile ice, such a solar emission could easily alter its charge distribution, rotational velocity, or reflective characteristics. Thus, the anomalies observed in 3I Atlas's luminosity and trajectory could represent the last visible link in a cascading chain reaction. Seismic pressure beneath Earth's crust triggering atmospheric ionization, altering magnetospheric fields, resonating with solar plasma, and finally influencing an object millions of miles away. It may seem implausible that forces so small could have such far-reaching impact, but the universe operates on principles of coherence, not magnitude. In plasma physics, even weak electric currents can produce large-scale reorganizations if they occur within resonant or feedback-prone environments. The Sun-Earth system is exactly such an environment, a dynamic, magnetically coupled pair exchanging charged particles and waves in a continuous flow. What begins as a small disturbance can grow exponentially as it cascades through layers of resonance. In this sense, an earthquake is not merely a geological event. It is a burst of electromagnetic data injected into the living system of the cosmos. Supporting evidence for this hypothesis comes from satellite measurements of low-frequency electromagnetic pulses that precede or follow large earthquakes. These signals, often dismissed as noise, have occasionally shown temporal correlation with subtle shifts in solar radiation flux. Additionally, ionospheric monitoring stations have reported rapid plasma density variations minutes after strong ground motion. While the mainstream interpretation attributes these effects to atmospheric shockwaves, a small but growing group of physicists suggests that the cause might be direct electromagnetic transmission from the lithosphere to the ionosphere, a literal pulse from Earth to space. If that energy finds sympathetic vibration within the Sun's vast magnetic network, it could, in theory, release or modify solar energy flow. 3I Atlas entered this dynamic system at an exceptionally sensitive moment. Positioned within the heliospheric current sheet, the thin, wavy layer where the polarity of the Sun's magnetic field flips the object would have been immersed in a region prone to electromagnetic instability. A small shift in solar field energy could have caused plasma density around Atlas to fluctuate, influencing its reflective appearance or even the sublimation of its frozen gases. From the perspective of astronomers, this would look like an unexplainable brightening or rotational shift, exactly as recorded in modeling simulations. When researchers input seismic-induced electromagnetic emissions into heliospheric plasma equations, they found that under certain rare alignments, feedback loops could amplify the signals for beyond their origin. Like ripples colliding in a pond, these energy waves can either cancel or reinforce one another. When reinforcement occurs at the right frequencies, the resulting wave carries far more influence than the original source. This theoretical amplification mechanism forms the core of the solar trigger hypothesis, the idea that an Earth-originated electromagnetic pulse, small as it may be, can reach the solar environment, resonate with solar plasma, and generate a reactive burst of energy that propagates outward again through the heliosphere. Such a hypothesis demands rigorous testing, but its implications reach beyond astrophysics. If true, it means that planetary bodies are not isolated actors, but participants in a larger, energetic dialogue. The Earth does not simply receive solar radiation. It contributes to the ongoing electromagnetic feedback system that binds the solar system together. It suggests that the Sun and planets are coupled not only by gravity, but also by frequency and charge, locked in a perpetual feedback loop of energy exchange. This interconnection could explain why certain solar and seismic patterns seem to echo each other, why a surge of solar wind sometimes follows a wave of terrestrial tremors, or why auroral intensities rise unexpectedly after earthquakes. To the researchers studying 3I Atlas, these possibilities are more than coincidences. They represent a deeper unity, a chain of events that begins in the movement of rock beneath our feet and ends in the shimmer of an interstellar traveler crossing the solar domain. It challenges our perception of cause and effect, revealing a universe where forces are not limited by distance, but connected by resonance, where every pulse and vibration may carry its influence across the expanse of cosmic space-ion, the aftermath of the complex sequence linking Earth's seismic activity, solar fluctuations, and heliospheric interactions. 3I Atlas emerged as a subtle testament to the universe's responsive nature. Unlike ordinary comets or asteroids, which follow predictable orbital and rotational patterns, Atlas appeared to have undergone a series of micro-adjustments in its structure and behavior, almost as if it were adapting to the stimuli that rippled across the solar system. This evolution was not dramatic or violent. It was delicate, measurable only through high-precision observations and spectral analysis. Yet, the changes hinted at an intimate interplay between an interstellar traveler and the forces it encounters, revealing that even small celestial bodies are part of a responsive cosmic environment. Observatories tracking. Atlas noticed that its reflective properties continued to fluctuate for several weeks following the initial anomaly. The brightness variations were irregular, distinct from the rotational modulation normally expected in such bodies. These variations suggested that the surface of the object had not only shifted in orientation, but that there may have been microscopic changes to its composition. Ice sublimation, exposure to charged particles, and minor restructuring of dust and metallic particles all contribute to the reflective signature of a comet-like object. The readings implied that Atlas's outer layers had reacted to some external energy, the combination of electromagnetic fluctuations propagated from Earth, the solar flare, and heliospheric resonance in a way that was detectable even millions of miles away. Infrared observations provided further insight. Using sensitive instruments aboard the James Webb Space Telescope and the Spitzer Space Telescope, scientists measured slight asymmetries in Atlas's thermal emission. One hemisphere appeared to release heat more efficiently than the other, suggesting that the energy absorbed during the interaction with electromagnetic waves and solar particles had temporarily altered its thermal balance. These subtle thermal gradients could influence gas release, create minor surface fractures, or redistribute dust in ways that shift the light scattering patterns visible to observers on Earth. In other words, the object was actively responding, adjusting its surface characteristics to accommodate the energy inputs it had received. Even the rotation of Atlas displayed anomalies. Its spin rate, previously consistent within predictive models, experienced minor accelerations and decelerations, detectable only through careful timing of light curves and photometric studies. Scientists proposed that this change could be caused by uneven outgassing, a process in which volatile compounds on the surface vaporize under solar irradiation, creating jets of gas that exert torque on the body. In this case, the outgassing might have been triggered not only by sunlight, but also by exposure to intensified plasma waves and electromagnetic fluctuations, resulting from the chain of events initiated by Earth's earthquakes and amplified through solar resonance. Such micro-adjustments exemplify how interstellar objects, though small and seemingly inert, can dynamically interact with their environment beyond mechanical and thermal adaptations. There were also subtle chemical changes inferred from spectral readings. Observatories reported small shifts in emission lines associated with cyanogen and diatomic carbon molecules, compounds that are commonly released from comets when they are exposed to energy input. These emissions fluctuated in intensity, hinting that Atlas's molecular composition was being temporarily energized or rearranged. While these changes were minor, they demonstrated that the object was not entirely passive. It was responding to the energy landscape surrounding it, transforming its immediate physical state to accommodate and release the effects of the cosmic interaction. Atlas's trajectory, however, remained largely unaffected in the gravitational sense. Its orbit continued along the path expected for an interstellar body passing through the solar system, and there were no dramatic deviations caused by the energetic events. This distinction highlights the difference between mechanical force and energetic interaction. The object did not receive a push or a collision, but was influenced through a subtler process of energy absorption and response. In plasma physics and heliophysics, this is akin to a conductive particle experiencing a transient charge imbalance. Its internal state shifts, but its macroscopic path remains consistent. The concept of cosmic adaptation extends beyond simple surface changes. It reflects a universe in which energy, matter, and movement are intertwined in complex feedback systems. When Earth's tectonic tremors propagated into the magnetosphere, when the sun's flare responded to the altered plasma environment, and when the heliosphere transmitted those effects to distant regions, Atlas was positioned to receive and react. Its response, thermal, chemical, and rotational, is a testament to the sensitivity of interstellar objects to their local electromagnetic environment. Even across vast distances, researchers liken this to a form of cosmic learning, though not in a conscious sense. Rather than intelligence, it is a process of physical adaptation, matter reshaping itself in response to energetic stimuli. The same principle can be observed in other solar system bodies, where surface regolith shifts after exposure to solar wind or ice, sublimates, and condenses in response to changing radiative input. Atlas, traveling from interstellar space, provides a unique laboratory because its baseline state is less influenced by solar system conditions, making its reactive behavior more apparent when it does encounter external energy. Another remarkable observation was the persistence of the changes. Even after the initial period of electromagnetic activity and solar disturbance had subsided, Atlas continued to show subtle variations in brightness and outgassing behavior. This persistence suggests that the energy imparted during the chain reaction had altered the object's internal equilibrium. Volatile compounds may have redistributed beneath the surface, or dust and ice may have compacted in new formations, subtly shifting the thermal and reflective characteristics. In this sense, Atlas had been transformed, not in a dramatic event, but in a quiet, enduring manner, an adaptation that could persist for weeks or months. The evolving state of 3I Atlas demonstrates how interstellar objects are active participants in the cosmic environment, not merely passive travelers. Their composition and structure are susceptible to electromagnetic fields, solar radiation, and resonant plasma waves, making them sensitive barometers of interplanetary energy. Observing these changes offers a rare window into the interplay between celestial mechanics and electromagnetic interactions, showing that even small bodies can reflect the energetic history of their surroundings. Through the lens of cosmic adaptation, Atlas becomes a narrative of resilience and response. It illustrates that the universe is not static. Energy is constantly flowing, interacting, and reshaping matter across scales both vast and minute. When Earth trembled, when the sun pulsed, and when the heliosphere carried those effects outward, Atlas adjusted to maintain equilibrium, exhibiting a quiet, observable evolution. These changes remind scientists that interstellar objects are not mere relics of distant systems, but dynamic participants in the ongoing, energetic dialogue that connects planets, stars, and spacefaring travelers. A la Kefter, the series of events that connected Earth's tremors, solar fluctuations, and heliospheric interactions. 3I Atlas settled into a quieter phase. Its earlier anomalies, the brightness fluctuations, thermal asymmetries, and rotational micro-adjustments, had begun to stabilize, yet traces of the cosmic dialogue remained imprinted in its structure. This period of calm presents a unique opportunity to observe the object not as a reactive body, but as a silent witness to the subtle forces that shape interstellar travel. In this state of tranquility, scientists can study the long-term consequences of transient energetic events, gaining insight into how objects far from the influence of planets still resonate with the universe's hidden rhythms. During this phase, telescopes continued to track Atlas, recording faint emissions and subtle light curves that reflect the internal state of the object. The changes were minimal, almost imperceptible to casual observation, yet they were consistent across multiple observation platforms. The thermal emission patterns showed that while the object had returned to a near equilibrium state, the energy imparted during the previous electromagnetic and plasma interactions had redistributed volatile materials beneath its surface. Pockets of frozen gases had shifted slightly, creating minor changes in sublimation rates that affected the visible coma and spectral signature. In effect, Atlas had remembered the disturbances. Its physical state subtly altered in a way that could be studied over time. Infrared spectroscopy revealed that while the outer layers of the object had cooled, traces of energetic excitation persisted. Molecules that had been temporarily ionized by the charged particle flux from the heliosphere were slowly returning to a neutral state. This slow relaxation process highlights the sensitivity of interstellar matter to even minimal electromagnetic and plasma disturbances. The phenomenon demonstrates that energy transfer across interplanetary space is not instantaneous or uniform. It leaves a lingering imprint that can persist for weeks or months, subtly modifying the structure and behavior of the receiving body. From a photometric perspective, the light curve of Atlas exhibited a gentle oscillation, a rhythm that suggests residual internal motion. This may be attributed to microfractures in the surface material or the redistribution of dust and ice that occurred during its adaptive response to the previous energetic events. Each rotation provides a glimpse into the physical heterogeneity of the object, showing how uneven heating and plasma interaction can create complex patterns of brightness. Such observations are critical for understanding how interstellar objects, often perceived as inert, are in fact highly sensitive to their environmental context. The period of calm also allowed for enhanced studies of the object's orbital stability. Despite the energetic disturbances it experienced, 3I Atlas maintained a trajectory remarkably consistent with predictions based on gravitational modeling. This observation reinforces the idea that while electromagnetic and plasma interactions can alter surface and rotational properties, they do not necessarily disrupt the overall path of a body in interstellar space. It demonstrates a decoupling between macroscopic motion, governed primarily by gravity, and microscopic behavior, influenced by energy absorption and resonance. The journey of 3I Atlas through our solar system, influenced by Earth's seismic activity, solar fluctuations, and the delicate resonance of heliospheric forces, reveals a universe far more interconnected than we often perceive. From the trembling of tectonic plates to the subtle flicker of interstellar light, each event demonstrates that energy moves in waves, linking planets, stars, and wandering objects in a continuous, dynamic dialogue. The anomalies observed in Atlas, its changing brightness, thermal asymmetries, rotational adjustments, and chemical responses are not isolated phenomena, but the tangible manifestations of these cosmic interactions. They show that even objects traversing the vast emptiness of interstellar space are sensitive to the energies and frequencies of the systems they pass through, adapting in ways both subtle and profound. Through the lens of resonance, electromagnetic coupling, and heliospheric dynamics, we begin to understand that the universe is a web of cause and effect, where the tremor of a planet, the pulse of a star, and the drift of a distant object are all part of the same energetic continuum. 3i Atlas serves as both witness and participant in this grand cosmic symphony, illustrating how matter responds, evolves, and maintains equilibrium amid the unseen forces that ripple through space. The events surrounding its passage remind us that no celestial body exists in true isolation, and that even the smallest disturbances can resonate far beyond their origin. Ultimately, the story of 3i Atlas underscores the delicate balance of the cosmos, the hidden connections that bind our planet to the sun and the wider interstellar environment, and the extraordinary sensitivity of matter to energy and frequency. It is a testament to the intricate choreography of the universe, a reminder that every movement from the quake beneath our feet to the light of a distant interstellar traveler participates in a silent, ongoing conversation that stretches across space and time. Through careful observation, patient study, and the integration of multiple scientific disciplines, we gain not only knowledge, but also a deeper appreciation for the profound and subtle forces that shape the cosmic landscape.